So this is Chapter 8, Lesson 1, Characteristics of Linear Relations, looking at line segments on a Cartesian plane. So again, in review, a linear relation is a relation whose graph is represented by a straight line. So the line could be an infinite line, meaning it extends indefinitely, or it could be finite, meaning it has a starting and a stopping point. In some cases, we're only interested in part of the line. We call this a line segment. So in the last unit, we looked at intercepts, we looked at domain, we looked at range. In this unit, we're going to look at length and we're going to look at slope. We're not going to look at midpoint. We're going to look at the length of a line and the slope of a line. We're going to demonstrate an understanding of slope with respect to being rise over run, which I think you guys remember from physics, from science, using a slope formula and recognizing that slope could indicate rate of change. And then we're going to compare the slopes of parallel and perpendicular lines. So again, if we start off, a line segment is the portion of a line between 2 points on the line. That's a line segment. If the endpoints of a line segment are A and B, we can refer to it as line segment AB, which could just be AB, or it could be AB with a line over top. So if we look at the length of a horizontal line segment, consider the line segments shown on the grid. Find the length of each line segment by counting. So press pause, take a look, write them in, and then press play. So the length of line AB would be 6 units. CD would be 3, 6, 9, 10 units. And EF would be 3, 6, 7 units. Part B, what I want you to do is I want you to pause and then I want you to write in what the coordinates of each of the line segments are. So for my endpoints, my coordinates, A I got 2 and 8, B was 8 and 8, C negative 3 and 4, D 7 and 4, E negative 9 and negative 6, and E negative 2 and negative 6. So in the next part, we complete the following. If I look at the difference in only the x-coordinates between A and B, so if I take the x-coordinate for B, subtract it by A, B minus A. So 8 minus 2, I get 6. If I do the same thing with the x-coordinates of D and C, 7 minus negative 3, which equals 10. And then if I do the same thing with F, it would be negative 2 minus negative 9, which would be plus 9. So negative 2 plus 9 would give me 7. Where have we seen these three numbers before? Right here in the length of our line segments. So how can the coordinates of the endpoints of the horizontal line segment be used to find the length of the line segment? We can subtract which coordinates? The x-coordinates. Okay. And does it matter which coordinate we subtract from which? Well, it probably works out better if we take the the right one minus the left one. So if we take this coordinate minus that coordinate, because then we're always going to end up with a positive length. But as long as you realize that length should be positive, even if I had gotten a negative 6 for this answer, if I had gone 2 minus 8, got negative 6 for my answer, it should still be something that I could draw the conclusion that the length has to be 6. So what we could write down is we could say it's the right coordinate minus the left coordinate. Okay, so now we're going to look at class example number 1. A line segment has the following endpoints, 2 and 8 and negative 5 and 8. What would be the length of AB? So if I picture this on a number line, 2 and 8 would be like here. Negative 5 and 8 is going to be over here. So there's A and there's B. So how do I want to subtract these? I want to start with the right one, which is A, minus the left one, which would be B. So 2 minus -5 equals 7. So the length of AB would be 7 units. So determine the length of line segment A minus 2 and B, and A plus 4 and B. So again, this one might be a little bit trickier to graph, but I can still think about it. A is the same in both, and B is the same in both. So because B is the same for my y-coordinates, that's how I'm going to get that horizontal line, because I'm both going either up or down by the same number of units. A minus 2 and A plus 4. Well, just to make it easier for argument's sake, let's assume that A is a positive number. Okay, so something like 3 plus 4, 3 minus 2. Well, 3 plus 4 is going to be larger. So that means Q is going to be somewhere over here, which then means that P is somewhere on to the left of it. That's what I want to determine, is which one is to the left. So now I have my right one minus my left one. So if I remove the brackets, I'm going to get a negative A and a positive 2. The A's will equal 0, so we can say they cancel out. And 4 plus 2 will equal 6. Vertical line segments. Very much the same as my horizontal, only this time we're dealing with vertical. So again, let's determine the length of these 3 line segments. So the length of GH would be how many units? 3, 6, 9, I get 12. So fill in what I and J, or line segment IJ and line segment KL would be. So IJ would be 5, and KL would be 6. Okay? So again, what I want you to do is I want you to pause and I want you to fill in what the coordinates of these endpoints are. So my coordinates for G is -3 and -8. H is -3 and +4. I is 1 and 2. J is 1 and 7. K is 6 and -8. And L is 6 and -2. So now we're going to complete the following using these coordinates. We're going to find the difference in the y coordinates. And we're going to go H minus G. So that's in the y coordinates. H minus G. So 4 minus -8, which equals 12. If I go J minus I, 7 minus 2, and I get 5. And then if I go L minus K, I get -2 minus -8. So the 2 negatives here would make a positive. -2 plus 8 would become 6, which again are the same 3 lengths that I got from counting. So how could I use the coordinates of the endpoints to find the length in a vertical line segment? I would subtract the y coordinates. And in this case here, how would I subtract? I would subtract the high y coordinate by the low y coordinate. Excuse me. So if we look at the next page, we have line segment RS has the following points. Determine the length of RS. So again, if I visualize and picture what this looks like, 1 and -4 is going to put me down in quadrant 4. And 1 and -9 is actually going to put me lower. So it's the top one minus the lower one. So it'd be -4 minus -9. The 2 negatives would make a positive. So I get -4 plus 9, which would equal 5 If I look at B, determine the length of a line segment, and this time it's algebraic, so I have no numbers. A and B to A and B plus 10. So of these two coordinates, which coordinate is going to be the top one, P or Q? The answer would be Q. So it will be the Q coordinate minus the P coordinate. If I simplify this, the B's will equal 0, and I will be left with 10. So really, finding the length of line segments when they are vertical and horizontal is not a lot of work. We can count, or we can subtract their x coordinates for horizontal lines and the y coordinates for vertical lines. But what happens when we have a diagonal line? Something that goes like this. I can't count this because I don't know what the length of this portion is. It's not really quite a half. I don't know if it's a third. How long is that line? So what I can do is I can go back to the idea of Pythagoras' theorem. I can make a triangle. And if I can determine what the horizontal length and the vertical length of my triangle is, I can use Pythagoras to solve for the diagonal. So let's do that with 4AB. So AB squared, the diagonal squared, is going to equal this side squared, which is 1, 2, 3, 4 units, plus the vertical length squared, which is 2, 4, 6, 8, 10 units. So 4 squared is 16, 10 squared is 100. So I have that AB squared equals 116. We are asked to answer this as an exact value and as a decimal. So AB would equal the square root of 116. What I would then want to do is I'd want to ask the question, does 116 contain one of those perfect square factors? Can I divide it by 4 or 9 or 16, etc.? Well, if the last two digits can be divided by 4, the whole thing can be divided by 4. And the only other thing I want to double check, can I divide this by 16? And I can't. This is actually 4 times 29. The square root of 4 is 2, and I get 2 root 29. If I calculate that as a decimal, my decimal equals 10.8 to the nearest 10. Okay? So what I would like to do is I would like to actually go through and do line segment CD. So I'm going to press pause, or I want you to press pause, and I want you to set up the equation. Okay, so if I set this up, I draw out my triangle to make this a right triangle, and you can draw it this way, or if you wanted to, you could have also drawn it this way. This would have also created a right triangle, so it depends which way you want to look at it. So I have one length of my triangle is 4, the other length is 8, so I have 4 squared plus 8 squared. So now at this point, I want you to finish this off and find out what CD would equal. Okay, so when I expand this out, 4 squared is 16, 8 squared is 64, I get 80. So CD would equal the square root of 80. Again, I go through my list. Can I divide this by 4? Yes. So if I can divide it by 4, check. Can I divide this by 16? And the answer this time is yes. I get 16 times 5. The square root of 16 is 4, so I get 4 root 5. That's my exact value. And then if I calculate that as a decimal, I get 8 decimal 9, or 8 and 9 tenths. So these are exact values. These are decimals. Okay, so the questions that I would like you to do, so questions 1A, 2A, 3AB, 5, 7, and 11.